Ladies and gentlemen, welcome back to Amateur Repair Time. I bought this radio at the flea market. A gentleman had two of them. This one and the other one is a GE, I think. But this is a Westinghouse. It's got a little bit of, it's seen better days. So it's got part of the logo broken off. It's not that big of a deal. It's generally pretty ugly looking. So I wanted to see if I could clean up the cabinet. It's just some kind of plastic or fiberglass, whatever that stuff is that they're made out of. I've got a whole bunch of them. But if I see one that I haven't, if I see one out and about, I like picking it up if it's cheap. So that seems like the volume knob. And it seems like they both turn at the same time. And this one's going to be a little bit of a basket case, I think. Okay, so yeah, these turn independently. It is turning the dial. And it's AM, FM, so maybe that's telling me, yeah, I think it says AM, FM. So that probably changes that. And then this is the thing. This says, well, I'm wrong. That says AM, FM. Oh no, they're just telling me this is AM and that's FM. Okay. So that must be volume. And I can't tell if the middle one is supposed to turn by itself or not. All right, so it seems like a volume. That's an AM, FM, and then the tuning. Nothing on the sides. But here's the deal, okay? When I peeked in the back, they kept all the tubes. So somebody thought they were pulling a sneaky one. But you know what? I've got all kinds of tubes, so they didn't get one over on me. Now this is an AM and an FM, which is a little more complex. I don't think I've done one like this. I've done AM, FM, more modern stuff. I don't remember if that one was, but you know, a couple of these. But I haven't done an old school tube one that was AM, FM. I don't believe that I remember, at least. So let's turn it around and see what the back looks like. This poor thing's been abused. Like they put paint on it. Why would you do that? Come on, folks. You marked out some of what I needed to read to make the video better. And so here it's showing us a couple things. 1, 2, 3, 4, 5, 6, 7. So there's at least 7 tubes, supposedly. What in the world is going on here? That's one heck of a cord there. I'm kind of glad they cut it off so that we're not tempted to plug it in. Okay, let me get this back off of it. So this just has a weird plug. We'll have to see if we can solder a new cord to that inside of there so that we can use that same disconnect. This is the screw that's supposed to hold the back on. Still has the loop antenna. We have 2 wires here that are supposed to go to here, which is the FM antenna, it said. 1 tube gone. 2 tubes gone. 3, 4, 5, 6, 7. Yep, so I guess 7. It has everybody's favorite selenium rectifier. Look at that. Can't wait to turn it on. I guess that's the output transformer. And then we've got 1, 2, 3, 4, 5. Are they all called IF units if it's FM as well? I don't know. The speaker looks pretty good. And here is our Tuning gang. Wow, there's only 2 gang? Like there's only, usually there's 3 on most of the ones I do. Yeah, I'll have to see how that works. Okay. So it all looks pretty good, actually. They just took the tubes out of it. They must have really thought they were getting one over on us. I hope these aren't the ones that get the silver mica disease. I haven't really had one of those yet that have screwed me up. They've got this permanently soldered to it. I don't know if that's how it's supposed to be. Maybe there was some kind of disconnect at some point. But we're going to have to disconnect that so we can take the chassis out. So, yeah, let me take those off so we can take this all the way off. And then let me see if I can get the chassis out so we can see what the bottom looks like. Make sure they haven't, like, super hacked it. I don't know about this hole here. That might have been where the filter cap was. So it could be that someone's actually already worked on this, or it could be they've gutted a bunch of it. All right. So I found an extra wire. Who knows? I also could not find a lamp. There's no kind of indicator lamp that I can see. So maybe that goes to that. I don't know. We'll have to look it up. Yeah, look. No? I don't know. We don't know for sure that these were the antenna. I think they are, because the ones on the tuning, the gang, and this one goes down here. Who knows? Schematics will help. Hopefully there are schematics. All right, let's count caps, shall we? Caps that definitely need changed. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. About 14 caps. That's not that big of a deal. We got a bunch of resistors to check, and we've got some of those dominoes. I haven't really messed with those yet. All that kind of stuff. You just read so much different stuff online. People will say, oh, those are this. They have to be replaced. And other people will say, oh, those are never bad. Got some disc capacitors. What do you think? It seems strange to me that there are only 2 ganged tuning capacitors. That's weird to me for being AM and FM. I don't understand how that works. But like I said, I haven't done many of these that have both, so I guess we'll learn. And then we've got, you know, these are coils. Coil, or that might be the oscillator. Very cool. So yeah, the thing up here was probably never there. This doesn't look like it's ever been touched to me. That was probably never even there. They're just using the same frame for a couple different models. That's be my guess. All right, let's see if we can find the schematics for this sucker. It might tell us some more, so we can figure out why I've got an extra wire. Seems strange to me. This is where the power plugs in, by the way. Let's see if we can look it up. All right, I've got the schematics, and here we go. All right, so this does not have a lamp on it at all. There is a slightly more complex version that does have a lamp, but this one doesn't. So yeah, so it's pretty straightforward. AM, FM. I don't know where that one extra wire goes at the moment. And like I said, I've never worked on one that's got FM. So I'm learning as I go. This selector knob's a little strange. I don't completely get what it does, but maybe we'll figure it out. Volume control. Selector knob. I don't know. I guess it picks what it amplifies, maybe. AM oscillator. AMRF. There's the antenna, of course. It's got a 12 BE6, which it says is the AM converter and the FM oscillator. I believe this is the FM connections for the antenna up here. 12 AT7 is the FM RF mixer. You know, it would be interesting to see if you can run it without some of the FM specific stuff in it. I don't know if they designed it where that's even possible. T1 is the first IF FM transformer. T5 is the first IF AM transformer. Interesting. Okay, and both of those output to 12BA6, which is the IF amplifier. So that 12BA6, okay, 12BE6 down here, 12BA6. So that runs into the second IF FM transformer and into T6, the second IF AM transformer. So the FM transformer outputs to 6BJ6, which is the FM IF driver, and the IF AM transformer outputs to the 12 AV6 AM detector AVC audio tube. Okay, so let's go back to the FM. After it leaves the FM IF driver, and like I said, all this is new to me, it goes to T3, the radio detector transformer, to a 12 AL5 FM detector. Okay. So when it leaves there, it comes down this way to one part of the selector switch. Okay, that makes sense. Okay, so if we follow the AM, when it leaves there, it goes to the volume control. Yeah, I don't completely get how they keep it separate. Like, how do they turn off the AM when they turn on the FM? The output I mean, any way you look at it, the output is going to come in on pin 2 there. 2, is that saying 2.5? So it comes from here. Just coming out of the AM detector. They have some way of turning it on or off. I don't completely understand how they're doing it, but I think it's brilliant however they're doing it. Selector switch S2 is shown in extreme clockwise position or the AM band. Extreme counterclockwise position is the FM band. All voltages measured from chassis ground using a 20,000 ohm voltmeter. Line voltage set at 117 volts AC voltage. Voltages should be as shown plus or minus 20%. To be installed for alignment only. Yeah, whenever you align the FM, it says to install a couple resistors. Okay, so here's what I'm going to do. I'm going to start at the beginning where the power cord comes in, which is actually right here. And I'm going to work through testing the resistors as I go and replacing the capacitors as I go. And when I run into something interesting, I will let you know. Now, there is right here near the beginning, it appears at least, there is this long wire. I'm not sure what it hooks to. I thought it might be what they're showing for the antenna here, but I was misreading this. Antenna coupling method. So if you have an external antenna that you want to use for AM, if you have an external FM antenna, you hook it up here. If you have an external AM antenna, remember it has the loop on the back of this board. They are telling you to bring in the wire, basically wrap it around where the loop is on the other side and tape it in place. So that's not a wire that's in the chassis. They're showing you that that's an external antenna. If you wanted to add it to the radio, you would just literally tape it where it will loosely couple with the AM loop on the other side, which is pretty cool. Okay, so let me start running through it and I'll see what I run into. Okay, so I've got one cap replaced, and right off the bat, this resistor is supposed to be 22, and this is usually the one that takes all the brunt, you know. So it's supposed to be 22 ohms, it's 60 ohms. But we also have this capacitor here, which is one of those little domino capacitors. And on the other side of it, it runs to our mystery wire. Our mystery wire that we don't know where it goes. But that's this wire. So it connects up to the FM screw on the back of the cabinet. So it connects to one of these connections. So we'll figure all that out whenever we get to it. But at least I know what it is, and it's nothing crazy. It was just one of the antennas. So there are actually 1, 2, 3, 4 connections to the antenna. And we have 1, 2, 3, 4, 5 wires. So we still got some more stuff to figure out, but we'll keep at it. We'll keep at it. All right, so I've been going through. The way I do it is I J-hook them. I like bend it around I cut the old one off, leave it on, and then bend the new one around. It's not as pretty, but you don't have to worry about you're stressing these connections, you know? So I don't want to, and that's kind of something that Shango talked about. If you don't watch Shango's channel, I don't know where you've been. Why in the world are you watching me? Go watch him. But he talks about that he doesn't want to heat stress the connections, and I had done a couple the first time I heard him say that, and I thought, well, I kind of like that they look so pretty. I kind of like that it goes from there to there, all the way to there, and it looks like it's one piece. But then after I worked on it a little bit, and I'm pretty good at soldering, but after I worked on it a little bit, I started seeing his point. Look at I didn't do this, but look at the flux and stuff around that. Okay, if I heat this up, well, this isn't a good example, but this one, if I heat this up, so I can get the old wire out, the old leg out, and put the new leg in, you're just burning the hell out of that socket, you know? How many times can you do that before the thing starts to fail? All it would take is it to melt enough that that metal pin doesn't stay in there very well anymore, and then you've got a problem that you introduced when you could have just done something a little more ugly, and you don't have to worry about that. So I'm kind of on board with what he's saying. So I've been slowly going through and following the schematics the best I can. And when I run into a resistor, I check it on the, by the color code and also on the schematic. And I've worked my way over to here, and I wanted to show you this freaking mess. You know, I don't really like to criticize the design of anything. So I'm not going to say that they shouldn't have done this or that they did it wrong or anything like that. No, maybe it's the only way they could have done it, but it just seems crazy to me. And by the way, as I go through, I'm writing down the resistance values of the resistors, and a lot of them are pretty far off. So this one's 4.7 meg, but it's 5.04 meg. That's not a big deal. And another thing, they just do that over time. These old ceramic resistor, carbon resistors, as they get old, they increase in value. So it's not the end of the world on some of them because our voltage is going to be higher at the wall anyway. But like this one's supposed to be 22, but it's 60. And the selenium rectifier we probably got to get rid of, and we're going to need a resistor here to get it down to 149 or whatever that is. You know, so I'm gonna have to do a bunch of resistor work because a lot of them are pretty far off. 22K, but it's 27K. That's just a little bit too high. You know, if it's 22K and it's a 20%, then it should be 260. It should be 26.4K, and it's 27.1. It's a little out of spec, but then some of them are like 22K, but it's 22.9, so that's fine. You know, but some of them are you can't check in circuit. So like this 470K and this 4.7 meg are both testing 693 somehow because of the way it's just wired in. So I'm gonna have to remove some of those to check it. I've got a 47K over here, but it's 57.6K. That ain't right. I've got a 220 here, but it's 474. And another thing, if you're testing them in circuit, you should rarely have any situation where it's higher in circuit than it is out of circuit because electricity doesn't really work like that. If I'm testing from here to here, which is what you're doing when you're going across the resistor, it doesn't matter what all's over here. If that's 220, it should be 220, or it should be less than 220 if it's going one of the other ways. So like if to go this way, it's 500K, but it's only 220 from here to here. As we know, electricity takes the path of least resistance. When I measure the resistance from here to here, it should always be 220. It's not going to go the long way around, you know, the hard way around. Now, if this is 220 and you're in circuit and this is shorter and it's like 10, when I test from here to here, I might get 10 because there's an easier way to do it, right? But you should never have a higher resistance even in circuit. There's a few exceptions to that. Like if there's a big fat capacitor somewhere, sometimes that screws everything up and it doesn't quite work right. And there's other instances where it can do that. But in general, you can check things in circuit and you should get a reading where it's right or lower, right? So for instance, this 4.7 meg is testing 693K, and you can see that this one is as well. So there's something going on here. Obviously that's screwing around with those to make two completely different ones test a different resistance. Once again, though, this one's 470K. It shouldn't ever be higher than that, even if it's wired really strange, right? So my guess is 693 is probably what this one is. It's high. And when I'm checking this one, I'm somehow short-circuiting around those two somehow, right? So we'll figure all that out later, though. But I'm going to have to order a bunch of resistors, I think. So anyway, all that to say, I'm going through. Now, I want you to see all of this stuff. So I'm going to turn on the light so you can see it a little better. All right, so like I said, I'm working through. Look at this crap. So, you know, the way they used to have all of them, they were axial, and they're really long. So we've got this long one, and this is ground, or I should say chassis ground, I guess. That's ground. And then the other end has a black wire on it that goes through this hole and I guess attaches to that transformer. Okay, and then this one has a wire on it, I think. I guess that's what I'm seeing. And I guess it attaches here. And then the other end has a black wire, a black covering on it that I guess also attaches to that transformer. And then we have this one, which maybe is coming from here. Right? And then it's coming over here and up to here. So it's between here and here, I believe. And then we have this little one here that is attached to here, but I would guess that's ground as well because it's so open down there by the chassis. You would think they'd be afraid that's going to short, so they must have, this must be connected to ground, like the solder, the support there probably goes all the way down. So I think it's running from there through the hole, maybe, to there, maybe? I don't know. So there's just a whole bunch of that you got to mess with. Then they have a resistor sticking through the hole. They have this resistor coming down with spaghetti on it, and it's sticking through the hole. It's a damn nightmare. What in the world? At least it doesn't have the rubber wires, though. All the wires look pretty good, so I don't have to worry about that. But luckily, the new capacitors aren't as long, which sometimes is good and sometimes is bad. So, you know, they're like half the size. So you can put them through a little easier. So I'm going to reuse the spaghetti and hook it back up, you know, and get it all figured out. And I've got new spaghetti if I need it. And then, of course, we've got the filter caps here that I got to figure out. But it's all getting there. So let me keep working through the caps a little bit, and we'll see how pretty I can get it. So another thing we're going to have to look at is the cone. Like the little cone is messed up there. Not the big one. What the world? I don't know if that matters. I'm going to try to use it like that, but it might give us all kinds of problems. So I got to keep working through the caps. I've got to check to make sure I've got all of those tubes. I believe I do. I've got a ton of tubes. If you saw that one video that I made, I bought a whole bunch off of a guy, and I had a bunch already. I've even got my own tube testing station full of tubes. Look, there's a tube box full of tubes. I've got tubes, folks, so I've probably got all of them that I need, but you know, I got to go through. So it's going to take a while. Also, we need to do something creative with this. So I'm going to continue to work through it, but that's all for now. Video's getting a little long. We'll come back and see if we can get the thing to actually make some noise. People have abused this poor radio. And then it was abandoned at the flea market. No one there wanted it. It's probably been at that flea market for a long time. That was a flea market I never go to. And I walked up and I saw it. It's probably been there waiting on me. It knew that here at Amateur Repair Time, we have the guts to try to fix this thing. Nobody else wanted to, for all kinds of reasons. You know, it's not particularly valuable. It's pretty dirty. It doesn't even have a pilot light on it. So I can understand why some people would shy away from such a job as this. But, you know, here on our channel, this is the stuff that we like to do. So we'll see you back next time. Until then, enjoy our theme song. We'll see you next time.
Ladies and gentlemen, dust-covered circuits sitting on a desk. In time, 50 years of rest, reading schematics and thrifting old parts. One more last week, old board new sparks, tracing faded traces, vacuum tube blows. Get it back to working by the end of the show. Bringing broken gadgets back to life, turning silence into stories, one at a time. We fixin' to fix them, easy as can be. Amateur repair time for you and me. Little machine, you carried history. Time to trace your path, bring your mystery. From open to singing, learn, preserve, repeat.